Hi everyone, Matt here. In this next set of videos we are going to be taking a look at assembly drawings, and in this first video we're going to be looking at what assembly drawings are and why we produce them. Assembly drawings are a bit different to detailed drawings, and the main purpose of an assembly drawing is to show how multiple components assemble in their working relationships. There are several different ways these drawings can be used to achieve different purposes, and we're going to go through some of these purposes now. So the first is to show how to assemble parts. So we've got here a sheet of drawings, and we have 6 different drawings or parts represented on this drawing, which are representing a device called a clamping device. Now if I was to give you each of these parts, how would you know how to put them together? From this drawing, it's not possible to tell how they all go together. So what we do is we would produce our drawing like this one here. So we have each of the different parts, which are the same parts represented on the left-hand sheet here. However, from this view, we now have them all in their working relationships, and there's enough information then to put the entire assembly together. So another purpose is to provide a complete list of all the parts needed required to assemble something. So we have a drawing here with 5 different views, and it's showing how all these, and you can see it's got a big range of parts that comprise this overall object, and we've got down the bottom here a parts list. And what you can see from here is this bottom part of the list here is all manufactured parts. So these are all things that are based off other detailed drawings. And we've got here drawing numbers down here. So this is why when doing our detailed drawings, it's important to add a drawing number so we can reference our drawings later in these assembly drawings. Now in the top portion of our list of materials and parts, we have purchased parts. So these are just standard parts. So we've got screws, hex screws, dowel, lock nuts, and these are just things, so we don't have a drawing number because these are things that are commonly available. You know, you could go down to your hardware store and buy them. What we do have though is a material. Now we don't necessarily have materials for our manufactured parts because some of these could be multi-component parts made out of several different materials. But as for our purchased parts, you can see here we've got HTS, so that stands for high tensile steel, and for our nut here we've got mild steel, MS. So the next thing is sometimes assembly drawings are used to provide designers with information on assemblies. So take for instance a catalogue that is showing an electric motor. So you might see something like this in the catalogue. It's an assembly drawing because it's got lots of different parts put together in one, but as you can see it's got dimensions on it. Neither of the other 2 drawings we looked at had dimensions, and that's because they weren't needed to assemble the objects. And you might note here that this is not actually drawn to Australian standards. This is a Swiss part, so it's got a European standard on it. But as you can see, the purpose of this drawing is to provide someone who is designing with it an idea of the overall size, the location of certain things such as the threaded holes and the mounting bracket and that sort of thing. So that's another use for assembly drawings. So another use for possibly doing an assembly drawing is to show how to disassemble a machine. So this is something you might find in a handbook or a guide on, say, working with your car, or you know, these are also similar to things you might find in Lego kits and something like that. So they're designed to be looked at by people who are not engineers, who do not know how to read orthogonal and detailed drawings. So they're generally quick, easy to look at, show how things go together. However, producing them would generally be quite a bit of work. As far as we're concerned, the main reasons we are doing these assembly drawings is for the first two purposes that I put up. So to show how to assemble parts and to provide a complete list of parts needed. In the next video, we're going to look at the information we need to put on our assembly drawings. So in this next video, we're now going to take a look at the assembly drawings you guys are going to be required to produce, and we're going to look at the important information that you are going to be required to include on your assembly drawings. So the first thing is, in our assembly drawing, you need to provide views of the assembly showing at least some portion of every different type of part used in the assembly. So there's a few bits of intricate details in this sentence. The first is you don't need to show every part, just as long as you've shown every different type of part, and you don't need to show all of a part, you just need to show a portion of every part. So let's go back to this drawing from our first video, and we're just going to pick a part here. So let's look at part 27, which is just a nut. So the first thing you can see is that part 27 is located on this section view here, which is labeled part section CC, and part 27 is the only bit of detail that is provided on this part section. So the sole purpose of this section is to show part 27. Section CC is this section up here. One thing to note is that this is drawn on an older standard, so you can see these arrows are coming away from our section line. If we were to draw these, we would rotate them 180 degrees so the tip of the arrow is on that line. Now, if you look at our projection that is coming off orthogonally over to here, you can see we've got that nut there again. And if you look down here onto our parts list, you can see that there are 4 nuts. Now, we have another one which you can see here. Now, from all this information, we can just label one, and then using these other views and the symmetry of the shape, we can show where the other 3 are. So this is an example of how we can use section views to show a part, and also how we don't have to show every single part of that, but as long as we show how to locate one of these nuts, and then the rest we know are symmetrical. So the next thing is, each different part drawn must be identified only once by a reference number. So if we refer back to the drawing we just looked at, we had 4 nuts, but we only labeled one of them. We can also look at this example here. So if we have a look at this part number 8, which is 2 lock nuts, you can see only one of them has been labeled. However, only one of our 2 lock nuts have been identified in the drawing. But if we go down to our parts list, you can see there are 2 of them. So we've got the total quantity here in the parts list, and from our drawing we are easily able to locate both of those lock nuts. So our next point is, if it is possible to assemble a device wrongly, the drawing or special notes must clarify the arrangement in a way that it is not possible from the drawing to assemble the device incorrectly. First thing, if we look at these nuts again, if you think about a nut, it can go on 2 ways. You can put it up one way, or you can rotate it 180 degrees and put it on the other way. For these ones, it doesn't matter which way we do it, but if you think about some types of lock nuts, they can be assembled, they require to go on one way or another, otherwise they can't actually be fastened on properly, or they won't perform their job correctly. The other thing is we have this section spring. Now a spring can also be, this spring in particular can also be installed either way up, and in this case it doesn't matter once again. And we have a diaphragm, so that can be installed either way up. Sometimes you might get a diaphragm that might have a special lip on it and can only be installed one particular way, but this is not the case with this particular diaphragm. So for this drawing there are no special assembly instructions required. So while on this example there are no special notes that we need, if these nuts were particular lock nuts or we had a particular type of spring or diaphragm, we might have to add a note that says be careful with this one, it can only be put on in a certain way, or we would have to have a special section view that shows something to show about how it's actually put on correctly. So another bit of information you might require is looking at the requirements in the assembly. So how much torque a particular bolt might need, or how much gap to leave between two surfaces. So let's come back to this example here. With this part here, we could use that and screw, because we've got a screw here, and we can use this to move the diaphragm up and down to give a particular setting. Now with our two lock nuts, we can tighten them against each other to set a particular gap here, or from the bottom of our thread to our spring. So we might have a requirement where we want the distance from our two nuts to be 20 millimeters plus or minus a millimeter. So important to note that this is a dimension that is only required in the assembly drawing, because it's not something specific to a part, so it's not going to be in any of the detailed drawings. It's a dimension that we need to know for just when we're putting our device together. We would also include a note with this, so this is telling the person assembling it what to do. So tighten nuts 8 together on the assembly so they're threading against each other so they lock into that position. And to measure this out, you could just use a ruler or something. All parts must be listed with adequate descriptions. So back to this example, if we take a look at this part number 8, the lock nut, you can see it's specified as a lock nut and it's an M12. From that is enough information that you could go out and buy a lock nut that's a size M12 and is made out of steel. One thing to note on this drawing is we have the drawing and material columns, which were separate on one of our previous examples. They are now combined, and the rest of our information here are in fact all from detailed drawings. So you'd refer to the detailed drawing for their full specification. Also worth noting is that they haven't included, they might not have had access to the drawing number, so they haven't put the drawing number there, but they've included the material. So generally when we're doing this, we'll split those into two, so you can have a drawing number column and then the material column. Okay guys, so in this third video on assembly drawings, we're going to take a look at some of the steps and things we need to consider when making an assembly drawing. So we're going to use this same example to start off with here. So the first thing to consider when making an assembly drawing is, since it's not necessary to define how each part looks, it may be possible to use only one view to represent the assembly of our device. So this is because the person assembling it should hopefully already have all the different parts required. So we would omit this view here. So this is similar to detailed drawings in the fact that we use as few views as possible, and even more so with assembly drawings, because you can get away with even less views than you would have thought. So for this drawing we obviously get away with just having one single view. So the next thing is we use sections extensively. So a lot of the devices or objects that we are considering will have hollow sections or some internal features, which means the use of sections is very, very important. When using sections, we need to make sure we section different parts differently. So we have a change in line spacing or direction for adjacent parts. As you can see here, we've got several different sections, each of which has different direction for their hatching. So here we've got hatching going up along this way, here we've got hatching going this way, and on this diaphragm we have a smaller gap between the hatching compared to this part 6 here. Many parts we look at in our assembly drawings are not sections, so solid parts, so things like our nuts and bolts, or any pins and keys, or other little things that might be a part of our assembly drawing. So generally objects that we know what the insides of are like, and you can look this up in the drawing handbook. It lists what sort of objects we do and don't section. And in this example, obviously here you can see that our screw, which is threaded, has not been sectioned, even though we seem to have this cutting plane coming right down the center of our object. So if we had sectioned this screw, it would not be providing any useful detail, and it is more useful to see it in this unsectioned view. So we also haven't sectioned our diaphragm support. However, we have sectioned the diaphragm itself because it's external and it looks better this way. So our next point is we number parts in an orderly way. So you can see here we've started with 1 here, and we go 1, 2, 3, 4, and then over here we have 5, 6, 7. So we have a anti-clockwise fashion as we have listed our numbers here. Now the reasoning behind this is because if you think back to our example from the previous videos where we had up to 30 parts and we want to look up where one particular part is from our part list, so we have the part number and then we have to find on our drawing where is part, say, 15. If the numbers are just all over the place with no real order to them, it could be time consuming just to find that number. So with this method we can go to the rough area where, you know, if we see 17 we can look there, and 15 should be in also the rough area. So just a few things for when we're doing this numbering. So we have our number and we enclose it in a circle. We then have a leader that comes out to the part, and it is normally terminated with a dot or an arrow. So you generally choose to use a dot or an arrow and not use a mix of both of those. So in this drawing we have gone with using a dot. So one other point is we try not to cross these leading lines, so we have things going up on a diagonal, but try not to make sure that these lines don't intersect each other. Next thing, no dimensions unless they are needed for the assembly purposes. So this is what we discussed in the last video where we added in a dimension to show the spacing between, well, they're not in this one, the nuts aren't in this one. So that's like what we discussed last time, where you might have a dimension to show a certain spacing required in the assembly of our two parts between each other. Finally, we include a parts list in the lower right hand corner. The parts list is listed upwards, so we have number 1 starting at the bottom here, and then we go up to number 7 here. We have the number of the item number, then we have the description, then we have drawing number and material. So sometimes these are combined into one column, however you can also have them separately. And then we have the quantity of each of these parts. If you've got multiple types of the same part, so you might have 7 M10 nuts, you would put 7 next to your M10 nut description. So now let's take a look at our clamping device from back in the first video. So the first thing is we have this part here, so part number 3, which is a cap screw, and it hasn't been sectioned, so we've gone down through here, but we've left this unsectioned, and we have 2 of them. So from having the device or the parts in front of us, we'd see there are 2 holes for 2 of these screws to go through. So we also haven't sectioned this part here, part number 5, which is a pin which allows for this handle to pivot. So it's part of a pivot system. We also have this part number 7, which is our stop. It also hasn't been sectioned. And you might just note on here we have this cross here, and if you looked up that in your drawing handbook, that represents that it is a flat surface, which compared to this other non-section part here, which is a buffer, it is actually a round surface. So that little cross, that's just a little detail you might want to note for when drawing, and that's in your drawing handbook. We also haven't sectioned our spring here, as from sectioning it we would gain no extra detail, and sectioning it's just tedious extra work. So another thing to notice is the difference in hatching between different parts. So we've got 3 parts all touching together, and you can see we've got different styles of hatching, so different gaps between the hatching and different directions to indicate that we're looking at different parts there. We've got our parts numbered, and we've listed them and we've ordered them in a logical fashion. So we've got 1, 2, 3, 4, 5, and then down the bottom 6, 7, 8, 9, 10, 11. So it's different to our last example where we had them anti-clockwise, but that being said, looking at this, we have still laid them out in a very logical and easy to follow fashion. So we also have our parts list, and we have ordered it starting at 1 at the bottom here, then moving up to number 11 here, which is our buffer. If we look at one of our parts, we've got enough detail here. So it's a diameter 12 spring washer made of spring steel. We need 2 of them. There's enough information in that description to go out and purchase one of those. And the same goes here for our M12 thin nut made out of mild steel. We need 2 of those. So once again, there's enough information provided in our parts list to purchase these parts. So on here, it's also good to note we have also included the scale. So you might have noticed we haven't included a projection system, and that's because we've only got a single view and it's not needed. You can't tell whether or not it is a first or third angle projection, so we don't need that. So that finishes up everything we need to discuss with assembly drawings.